Our next speaker has 25 years of industry experience. He's done that all the time. He was formerly a consultant for Sun Microsystems and a chief architect for GFI Group. He's a patent holder of a method to convert XML data structure into relational databases. Please welcome the enterprise CTO of MarkLogic, Ken Krupa. Oh, I shake his hand. Get a photo up. Thank you. Okay, all right, we got that out of the way. So thanks for attending. I appreciate the audience. I too, like Minerva, I am a native New Yorker. I've lived in 4 of the 5 boroughs of New York City. Never quite made it to the Bronx, but I spent enough time at Yankee Stadium to get honorary credit. No, Yankee fan. Today I live in the borough of New Jersey, across the lovely place. Check it out. Not yet. Okay, but anyway, that's. So I've been at MarkLogic for 3.5 years. The other more than 23 years, more than 20 years prior to that, I spent most of my time on the customer side, either working for buyers of technology or consulting. But I really enjoy being at MarkLogic. I particularly enjoy having to speak here, getting the opportunity to speak here at the UN. If you do public speaking, I'm sure many of you do, you sometimes dream of speaking at venues like this, particularly on a Sunday. Yeah, so yeah, I'm really grateful to be here. All right, let's get right into it. We're going to talk about database or data convergence in today's technology landscape. And we'll start with models and schema. And it sort of makes sense to start here because we've been dealing mostly with models and schema if we've been dealing with relational databases. I'm going to walk through some examples of modeling, and then we're going to do some convergence, okay? We'll start with the CRD, this entity relationship diagram here, a very simple one. We've got customers, transactions, and products. We're all consumers at some level, so this shouldn't be too much of a surprise to us. I'm going to go through 2 different schemas, 2 very simple schemas from a relational lens. The first is this one. We've got customers, transactions, products, and T lines. I guess those are transaction lines. And if we look at it, we see on the customer table there's a phone, there's an address, and we go, wait a minute, there's only allowed 1 phone on this particular model? Okay, kind of interesting. Address, is that the whole address or the street address? Ah, no, there's city, state, and zip. So we can look at the schema and intuit some things about the data, but not all the things. Let's go to a second model. This model is actually a little bit more normalized, third normal form for those of you who are familiar with the term, where in this model we can have multiple phones connected to a person, multiple addresses connected to a person, and then we've got the orders, the order lines, and this is following a much more normalized format until we get to products where we see supplier ID, but we don't see another table. So we go, okay, maybe what they did is they baked some information, some intelligence into supplier ID, where you could figure out stuff about the supplier. Okay, the point I'm making is that these are just 2 models for customers. How many, a show of hands, how many of you work within a large organization, say more than 1,000 people? Okay. How many of you deal with customer data? Same group? Okay. How many of you have 2 or fewer models for customers? Okay, no show of hands. That's what I figured. Most of the models look like this. Okay? They look like this where, particularly with customer data, they multiply significantly. In fact, there's a standard technology term for this called EOUS. Anybody know what this means? Okay, I figured not, but you'll know after today. ERDs of unusual size. And this particular piece is quite nefarious. Okay, who knows which movie I'm referencing? Yes? Time's up. Yes, but the movie I'm referencing is Princess Bride. Thank you. Okay, geek in the audience. We got Princess Bride. Okay, sorry, that's my digression. So these EOUSs, these entity relationship diagrams, thank you for that, of unusual size, these can fill up walls the size of this one, particularly in large organizations. And that's even if you don't consider this one, the STAR schema. If we're just talking about our OLTP systems, online transaction processing systems, that fills up a wall, but then you start building data warehouses, and what do? We create another schema, and a few other ones for the data marts. And that's because third normal form is not sufficient, and you depend like ETL, extract, transform, and load, to move the data, to figure out the best model, to get the little bit of information that we need from the star schema, or maybe a lot of information. So let's look at our example models and see what we can do with that, maybe get into a star schema. Oh wait, we looked at the first table and we go, wait a minute, on the phone column, looks like there are 2 phone numbers there. Go figure. So what probably happened is the developer said, you know what, we need to try more than 1 phone number. I don't want to bother the DBA, so I'll just do this. It's kind of like cheating on the DBA. Who's cheated on the DBA? It's a safe place, no joke. Okay, who knows somebody who's cheated on the DBA? All right, more hands, thank you, thank you. And for those of you who answered yes to the first question, if you are dating and married to a DBA, I cannot help you, it's not this kind of conference, but anyway. Okay, moving on. So phones, right? So we do this sometimes. We make compromises, developers make compromises to try to get around some of the constraints of the model. And then, of course, this one with the supplier ID is kind of interesting. There might be some intelligence in there. But we've been talking about phones. Hey, wait a minute. I didn't have phones in my star schema. Let me take a quick peek at that. Considering all this data, we got these nice relationships. And in our star schema, what do? We go, well, I want to do robocalls to people who spend a lot of money. So I want to take a look at the phone data. Now, one particular modeling technique might be to make phone a dimension. It might not be the best one, but let's just go with that. We're adding a dimension to the fact table. Well, those changes are costly. When you add a dimension to a fact table, what are you going to do? You change the granularity, so you're going to drop it and recreate the whole thing. And these things have oftentimes billions of records in them. And then you've got to create another table just to house the dimension data. You've completely changed the granularity of your data. And all of that work has to be done before you get that value that you wanted out of that data warehouse. It looks something like this. And I've used relational databases for my entire career, which, as we know, is more than 25 years. Thank you, Eric. And they serve a purpose, and they do wonderful things. But what we're finding is that they have trouble scaling to today's pace of change, because business requirements change. Change is all around us, right? It's accelerating at a rapid pace, and it's the new norm. We expect our data, the data that we looked at last year, the shape of it is very different than the way we look at it this year. And this is not scaling for that. So I'm here to talk about a better way, okay? By example. Let's get into that. So the first piece of convergence that I'd like to talk about is simply using document data, or object data. If you take a look at this, it's a lot more natural looking. And these are some JSON objects. This could be XML documents. And you see that it's self-describing, and that it has a more natural representation of the hierarchies that invariably exist, or repeating groups, like multiple phone numbers. The key thing about this is that different shapes are perfectly fine in the same database. Why? Because the schema is the data. It's not this orthogonal piece of information sitting in a catalog table that you have to consult, or that you have to conform to if you're going to load any data into your database. If you put some information with your data that describes the schema, just put it in the database. And if you don't, that's fine too. Just index it like Google. These are our expectations today. This is what we should expect out of our data. But it gets better. Okay? So you can do harmonization. If you're accepting 2 different definitions of the customer, or 30 or 100 or 1,000, that's fine. You can store that data exactly as it exists, and you can get immediate discovery out of it. You say, all right, zip code and postal code mean the same thing. That's cool. I can search across all that. But what if I want to conform it in some way? We want to allow that too, because there are good reasons to do that. I'm not here saying, hey, just have your data run willy-nilly all over your database. Saying, accept the data as is, but then also have a mechanism for conforming in the same place. That's what I'm talking about on this next slide. You can harmonize your data. You can, as I did in this example, decorate the schema after it comes in without having to consult the DBA. Okay? What you'll notice is there's a canonical section in this example. There's also a source section. The source section is exactly how it came in, because that has value. You don't want to throw data away unnecessarily, because oftentimes you will regret it. You say, oh, that information, what the regulator cares about that information. Let's go back to where we got it from and see if we can reclaim it. No, just store everything. And then promote things as needed to a canonical form. We call that the envelope pattern in MarkLogic. Okay, it's a technique that we use. You can go even a step further. You can take the metadata, the reasons why you did what you needed to do with your data, and put it with the data as well and query it. Okay, some people call that lineage or provenance. You can do all of this without re-ingesting from the source information. And then, if you have yet another schema, a third, fourth, 10th, 20th, 30th definition of a customer, you can add that too. No penalty for doing that. Okay, so entities are documents in MarkLogic's world. And although I didn't cover it at the beginning, MarkLogic, we call ourselves a multi-model NoSQL database. These are one of the models that we support, document-oriented or object-oriented model. But what about relationships? Okay, not the relationship between you and your DBA, but relationships amongst the pieces of data that you have. Sorry, I'm touching a nerve over there. So, for that, I actually have a video. And I'm going to do what, this is the second most dangerous thing you could do in a presentation. The first is to have a live demo. The second one is to try to time what you're saying to a video. Okay, because we kind of did this on short notice. But here's what we got. So, relationships. And we're fading to black, so hopefully you guys can see this, but I'll do my best to describe what's on there. We have our multiple different schemas in this case, the multiple different definitions of customers, and we still have the relationships that we would expect between the data, right? The products, the transactions, and the products, the customers, products, and transactions, right? So that still exists, and you see the relationships as I circle in the as-is data. Now we have those numbers, and that's fine. But that's actually not enough context. It's enough context if you know that those are related, like in a relational database, if you happen to know the primary key and foreign key relationships. But there's actually a more powerful way to do that, with specific named relationships. Triples, subject, predicate, object. And we had a graph database up earlier, and they talked about things like RDF, Resource Descriptor Framework, and Sparkle. So these are W3C standards around modeling things as triples. And triples are specific named relationships between things. You put a lot of them together, and you form a graph. That's what's going to happen in this video any second now. I promise you. And so all I'll do is I'll vamp. Oh, there we go. Okay. So yes, the animation worked. And when you chain these relationships together, these individual relationships between things, you form a much more powerful construct than the weak relationships of relational databases. You can query those relationships through this language called Sparkle. In this example, we're looking for customers who bought a particular product, okay, through the relationships. But you could go one step further, you could go many steps further beyond that. You could do something called inferencing. Inferencing is a powerful capability where you can create rules that say, if a customer has an order containing a particular product, then we can infer that they bought that product. So this is a very simple example here, where I'm conflating two relationships into one inference, but it's limitless in terms of how you can do it. So now Sparkle gets a little more clear, a little more succinct. All right, tell me the customers that bought products. But then we start to decorate this graph with more relationships, more interesting information. In fact, in the last presentation, the folks from the city of New York talked about open data. There's a lot of open data in this format called RDF. Incredibly powerful stuff. So you can take the data that you have, decorate it with other information on the fly, much the way we could decorate our schemas on the fly, we could do the same thing with the relationships. It could be internal data or external data. That's the power of triples in an NoSQL world. It's more powerful when you have it in a single platform. Because what better place to put the information about the relationships of the data than inside the documents themselves. Okay? Yes, there are specialized databases out there, but it's much more powerful that the same database can make the connections between everything, instead of having to try to stitch it together. from a technical perspective. So what we do, we put the triples inside the documents. We have a first-class Sparkle engine, distributed scale-out Sparkle engine that does this. In addition to the other stuff we have. The ability to create schema, to create data of many different shapes on the fly. The ability to query it like the way you query Google. And to do things like Sparkle. So that's the first takeaway in our convergence message. Document plus graph is a much more capable model than relational. And I say this with a lot of respect for relational databases. They're not going away. But the things you could do from the perspective of agility and managing change are much more powerful with this paradigm. Okay, so I'm going to bring it up a little level, not to 30,000 feet, but I'm going to talk about enterprise architecture. How does this apply inside of an enterprise? Okay, great, you're armed with this information. You've got this product, this multi-model enterprise NoSQL database that can do these wonderful things with data. What do I do? Okay, well what you can do is take a look at your estate. Let's go back to the other integration patterns. They're not going away either. The enterprise data warehouse, Bill Inman was is the person largely credited with the term. And if you look at some of the terminology, non-volatile, they don't exactly scale for some of today's needs. They have their place. But if this is the first place you're going to integrate data, you're already behind the eight ball. There have to be other places to go. The other takeaway about this particular slide is that this refers to what we call an observe the business function. The enterprise data warehouses are about analysis, discovering things about your business. It's not the run the business stuff of the OLTP world. To integrate in the run the business function of the OLTP world, you do things like this. Service-oriented architectures or other flavors of enterprise application integration. That's the run the business function. And in your enterprise, if you take a very simplistic view, it looks something like this. Okay? You've got so let's see. Yeah, on your left, so is the run the business function. On your right is the observe the business function. In the middle is, we'll call this enterprise data management. But we have this two rooms distinction between the two. We've got this stuff in the middle that links them together. And I ask you, does that stuff in the middle scale for what you're trying to do today? These enterprise data management functions exist to manage this transformation. They rely on copying data to suit various needs. And that's becoming a problem because, as we know, big data has entered the picture. 3 V's that were mentioned earlier. And you hear a lot about big data, but guess what? You probably hear it about more exclusively within the domain of observe the business. Big data analytics, real-time analytics, let's analyze this. What about the operational big data? What's going on there? That's where tens of thousands of transactions per second are the kinds of things you have to worry about. That's where you got to worry about things completing or not, knowing if they don't, and not losing data. It's a different game. So where do things stand today? I won't belabor this slide because this is a build slide, but I'll go through it really quickly. That place in the middle, that enterprise data management place, whether it's all the ETL that you're writing, forget about millions of lines of code, thousands of programs, tens of thousands of programs in some enterprises, okay, where the logic to try to conform this data lives. Or master data management. That's a really interesting concept. It's almost like saying, hey, we did such a bad job trying to get a view of our customers across all these silos. Let's create another one and try to figure out where our customers are. All right, show of hands. How many have been, and there probably are some, but how many have been on a very successful master data management initiative that completed? Okay, we've got some. Good. I'll say that. You guys are actually in the minority. Okay, you've probably done a lot of things to deal with some of the constraints of a relational model to deal with MDM. This, and I'm not picking on MDM, but this notion of having all of this stuff between your observed business and your run the business functions, these people-centric processes, that's causing a gap between analysis and operations that is growing. And that's where most of the spend is. Read these from Gartner. I don't know if these documents come from Gartner. Most of our spend is in that middle piece. Think about it. If you divide them into 3 sections, the observe the business section, we know that there's intrinsic value there. It tells us how our business is doing. The run the business section, that's what runs the business. That's what makes us money. The stuff in the middle, it's kind of tough to put a value on that. Yet that is where we're spending most of our money. So what we got to do is we've got to right size that. We've got to converge those. And we converge those with a new enterprise integration pattern that fixes this picture. This picture that says we've got people in the middle of this integration, very people-centric processes. I've been there, I'm sure many of you have as well. And let's make it data-centric. Let's put data in the middle. Put data in the service of people instead of the other way around. And we call that pattern operational data hub. We gave it a name because we've been doing it for so many years with our customers that we realized, right, we should call it something. And this is what it is. It's convergent, as I mentioned. It's contextual. The things I talked about earlier, the data, the metadata together, the provenance, the agility, the flexibility to be able to do things with your data without having to rely on that 6-step process that I showed you earlier, to be agile about it. More importantly, though, this is a complementary pattern. The message here is not to say go and rip and replace everything, go and retire your data warehouses and retire your OLTP systems. No, they have their place. It's to say that we've been relying on the existing tools for too long to do things that they were not designed to do. So the second takeaway here, it's a bit longer. They say to put the pithy summaries up here if you can, but I did this again on short notice. An ODH brings agility and converges the observe the business and run the business functions in a way that allows you to be more nimble to meet today's challenges. Okay, so how does this fit in? I mentioned it's complementary. Well, the first is if you have an EDW, don't make it do more than it should do. EDWs are typically more batch-oriented, and maybe you have an operational data warehouse that is a bit more real-time. But what we're discovering with our customers is that discovery is not a one-way street. It's not a read-only operation. It's very conversational. You know, analysts work together and they share information. And they'll share it by phone, they'll share it by email, take a look at this report. Well, you know those triples I showed you earlier? Those are machine-readable facts that you can do really cool things with. They also happen to be a way that you can talk back to the database. Pretty cool stuff. So use some of that. Put that at the center of the enterprise. If you have a service-oriented architecture-based infrastructure, which everybody does, I know a lot of banks do. You work for a bank here in New York. You're familiar with this. And those are very function-focused. This notion that says, okay, let's do the bare minimum we need to do to integrate. We'll put some message on a message bus, and there are these black box processes at the end of these service buses. We don't know what they do, we just know that they accept this message, and then they do something, and they give us a thumbs up or a thumbs down. That is the least common denominator way to do integration. And you know what? The work that you did to describe that message flow, a lot of banks have done this with something called FPML. It's a markup language to describe trades and derivatives. They spend a lot of time doing it. All of that knowledge, if you're not saving it as is, gets thrown away. And you don't get to take advantage of it. So, complement your SOA infrastructure with an operational data lake. And then finally, if you have a data lake, the message here is copying something to HDFS on its own doesn't magically make it useful. You have to put context on top of it. Again, data lakes are great. But, and in fact, some of these comparisons are perhaps a little dated. Some of the data lakes have a more real-time nature to them. But again, it's two-way analysis and operations. But the operational piece of it, the transactional piece of things, there are emergent cross-line of business transactions that occur. We have a customer at a bank. They were trying to meet a regulation, Dodd-Frank regulation called uncleared margin. And what they needed to do was they needed to track a bunch of trades that violated this constraint. And they said, okay, well, we know how to identify them. Where do we put the workflow to track those? Well, there's 30 different downstream systems covering all the different instruments. And you can't change those 30 different systems. They had it in their operational data hub. It's a transactional system, and they said, we could track it right here. That's an example of an emergent cross-line of business operational function that you can't do in an enterprise data warehouse, and you certainly can't do in the single source systems. You can do it here. Okay, so I put a few customers here. These aren't supposed to be sales slides, but it's more to talk around the concepts. And I only have a few. We have lots of customers. These are some of the fun ones. I mentioned one of the banks. They're here. Aetna. They built an HR hub and a customer patient hub. Healthcare.gov. How many here are familiar with the Affordable Care Act and healthcare.gov? Right? That should be everyone. So yeah, we're the database behind that. BBC. And then my favorite is Saturday Night Live 40th anniversary app. Please download it. It's awesome. It's hilarious. We're the database behind that as well. A lot of semantics are used there to track relations between things. Okay, so here's one commercial slide before I sort of close it out. The summation for us is we have a database that's multi-model. If you look at what we are in comparison to other products in the marketplace, you would say, they're three different things. They're an enterprise-grade search engine. They're a document plus object database. They're a triple store. Lots of geospatial. We put it in one engine because our customers told us to. So it's easy to get data in, it's easy to get data out, a powerful indexing capability, and then we're 100% trusted. If you're going to deal with operational big data, things that run $87 trillion derivatives portfolio, you have another customer, their derivatives portfolio is that large, you probably figure out who it is if you Google that number. We're the operational data hub for their post-trade processing. So you have to be trusted. Those features that were mentioned earlier during the enterprise DB discussion around ACID transactions, very important. So that's the last takeaway. Enterprise capability does matter. If you're going to do something different, and you're going to challenge the status quo, you want to have a platform that's going to have your back when you do it. Because you put a target on your back already, you say, let's do something different. And you don't want them to say, well, the technology was immature. So for us, the maturity of the technology is important. So that's it. That's me. Thank you. If you want to hear more,